How do we perform scalar multiplication with matrices? Well, first of all, a scalar multiplication means that we're taking a number, a scalar, and we're multiplying that by a whole matrix. So C would be a single number, a single element, and we would be multiplying it by some sort of n by m matrix. And the rule is to multiply each entry by that scalar. So you'll see C has been multiplied by each of these terms in the matrix. So here, we're going to just multiply the positive 3 to each of these. So 3 times 6, 3 times 2, 3 times 4, 3 times negative 3. And that's the product of 3 and this 1 by 4 matrix. Here, we're going to still multiply negative 4 into that whole thing. It becomes 12 kj, negative 4h squared, 24j, 0, and 8. Here, you can follow the order of operations, which, yes, the distributive property works here, but typically it's actually faster to add them and then multiply afterward when you can. So I'm going to leave the 5 outside, add the matrices, and the sum of these two matrices will be negative 9, negative 10, 5. Again, I'm adding corresponding elements. So for example, this 3 was the 5 plus that negative 2. Now I'm multiplying by a scalar, so I can distribute that into each entry. We don't technically call it distribution. The distributive property specifically refers to when you're multiplying and the individual terms are added together. Here, these terms are not added together, but the process is very similar, which is why people will informally call it distributing. Here, you'll notice that this looks like addition, except there's a plus 4 in here. This plus 4 is not adding 4 to anything. This is saying here's an object, here's a matrix, here's another matrix. We're going to multiply this matrix by 4 and then add. Still, order of operations says multiplication, multiplication before addition or subtraction. So these are not supposed to be division signs. We leave this vector the same. I call this a vector because we can write a vector as a column matrix, as a matrix with a single column. But you could just call it a matrix as well. And I'm distributing that positive 4v plus 24, negative 24v, and 6u, oh, whoops, that should be 24. Now we add corresponding entries. So v minus 5 and negative 16v become, well, negative 16v and positive 1v become negative 15v minus the 5. Here we have a quadratic, v squared plus 4v plus 24. Here these are not like terms, 4u minus 24v. And here we have 24u plus 2. That's supposed to be a 2. So that is how we multiply matrices by scalars.